What if Earth's topography was inverted? Imagine waking up in a world where the face of the Earth has been radically transformed. The features we've always known, towering mountains, deep oceans, sweeping valleys, have all switched places. The highest mountains now sink as the deepest trenches. Expansive seas now rise as massive continents. Islands sprout where there were once abysses and lowlands. Cities adjust to life on top of what used to be the seabed. This is not just a small shift. It's the complete inversion of Earth's topography, a scenario that flips our home planet inside out, turning every elevation into a depth, every depression into a peak. What would such a world look like? How would life adapt, survive, or perish on this upside-down Earth? To imagine this scenario, we must first understand what it means for topography to be inverted. On our current planet, mountains like Everest tower 8,849 meters above sea level. The Mariana Trench plunges 10,994 meters below sea level. If we invert, the Marianas Trench soars as a high-altitude range, while Everest becomes Earth's deepest abyss. Plateaus, valleys, basins, and all other landforms would switch their nature in this great reversal. Oceans, which currently cover about 71% of the Earth's surface, would become elevated continents. Vast, unfamiliar land would emerge from beneath seas, while familiar territories would drown beneath the newly sunken highlands. Atmospheric, climatic, and ecological conditions would shift on a cataclysmic scale. Civilizations would be challenged, perhaps thrust into another mass extinction, or forced to repopulate in new, unforgiving landscapes. But let's take a closer look, step by step, at how such an Earth would come to be, and what wonders or hardships would await its inhabitants. In this inverted world, step one is the recalibration of Earth's surface. The continents and ocean beds swap roles. The greatest ocean basins, the Pacific, Atlantic, and Indian, become the planet's highest plateaus, covered, at least at first, by the sediments, corals, and remnants of ancient deep-sea life. The Mariana Trench, Challenger Deep, and other great trenches rise above all as jagged, elongated mountain ranges, their steep sides exposed to the air, perhaps looming like the worst peaks of the Himalayas, but much taller. The land we know, North and South America, Africa, Eurasia, Australia, Antarctica, become deep chasms, flooded by water that drains from elsewhere. The Swiss Alps, the Andes, the Rockies, the Himalayas, all become sites of enormous sinking valleys. Rivers reverse their courses, tumbling into these great holes, if they exist at all. Giant lakes may form on the tops of new plateaus, where the sea used to lie. But Earth is more than a two-dimensional sea of heights and depths. It's a complex, dynamic sphere, and the sudden inversion of topography would affect everything. The atmosphere, the oceans, the weather, the very crust of the Earth itself. Imagine standing on the summit of Mount Mariana, gazing out across the floor of what used to be the Pacific Ocean. Gone is the endless expanse of water. Instead, you see a high-altitude desert or tundra, battered by sunlight and cosmic rays with little protection, the air thin and cold even in equatorial regions. The biology here would be extreme. The deep ocean creatures that once lived here, giant tube worms, alien-like fish, would be vanished, their habitat replaced with rock and dust, with only the hardiest extremophiles able to persist. Along the edges of this vast plateau, walls drop away precipitously. Former continental slopes, now vast escarpments that dwarf anything seen in today's Grand Canyon. The summits of the Great Trenches would be the highest points on this new land, jagged ridges punctuating the panorama, casting deep shadows across the shelf. Meanwhile, the continents themselves, now the world's lowest points, would be transformed into gigantic basins. Where the Himalayas once thrust up into the sky, now a gaping depression, perhaps miles below the new sea level. If the entire volume of Earth's water remains unchanged, then vast new oceans would flood these land depressions. Picture the Indian subcontinent submerged, the Ganges Delta, a sprawling bay at the edge of the new continental sea, where Himalayan foothills lap apart at the lapping waves. North America's greatest mountain chains, now underwater trenches, would make for the new planet's deepest abysses. The most familiar parts of our world, cities, forests, plains, deserts, would be gone, lost under inland seas. What remains might be obscure mountaintops, elevated above the new sea level, but still mere foothills compared to the new Mariana Alps or mid-Atlantic highlands. This transformation would not be smooth or gentle. Geological processes are slow, measured in millions of years. But in this hypothetical scenario, the inversion happens at once. The consequences are staggering. First and foremost, Earth's climate would be rewritten. The new highland plateaus of former ocean floors would reach higher than any present continent, their thin air making for frigid, desolate expanses. The circulation of air and weather would become chaotic. Oceanic currents, once powered by the warming and cooling of vast bodies of water, would be severely altered. If new seas formed in the low-lying former continent basins, they'd be smaller than today's oceans and enclosed, surrounded by sheer cliffs or steep escarpments. Evaporation from these new inland oceans would shape the weather, perhaps causing new mega-monsoon patterns or extreme storms as moist air rises up the enclosing walls and drops its load of rain. The biosphere, the diverse array of life on land and in the seas, would suffer the bitterness of catastrophe. Countless species would perish as their habitats are upended. Coral reefs would die atop rocky, exposed former seabeds. The forests that once blanketed continents would vanish beneath deep water. However, new forms of life might find niches in crevices of the now aerial trenches, or in the sprawling new lakes and seas. Evolution would be forced to start anew, picking survivors from the relics of old ecosystems. How would humanity fare in this world? Our cities, mostly located near coasts or on fertile plains, would be submerged. Skyscrapers in New York, Shanghai, Mumbai, and Tokyo would disappear below the new seas, their steel and glass left to corrode, visited only by deep-diving machines or the occasional, bewildered oceanographer centuries later. Survivors would be forced to migrate to the new highlands, the vast, austere plateaus of old ocean floors. But establishing settlements here would be daunting. The thin air, harsh climate, and meager soil would test the limits of human ingenuity. Traditional agriculture would struggle. Food production could suffer. The nearest analogy would be Tibetan plateau communities or Andean villages, except covering the entire world. Alternatively, some groups might establish themselves along the shores of the new inland seas, where river deltas might offer more favorable conditions. Trade, communication, and transportation would change, as new geographies dictated the shape of commerce and culture. Some current islands might vanish beneath new waters. Others, like Hawaii, formerly volcanic peaks, could become deep canyons or even the epicenters of vast flooded basins. The Mediterranean Sea? Its silt-choked floor could now soar as a mountain-bounded desert or a high-altitude lake, the ultimate tabletop plateau. Let's turn now to Earth's poles. Antarctica, with its broad plateau of ice, would become a massive deep-well area, one of the deepest on the planet. What about Greenland? Its ice cap, once rising 2 kilometers above sea level, now creates an enormous depression, perhaps flooded with seawater, birthing new, deep inland seas that could rival or exceed today's oceanic depths. This dramatic shift in topography would also reshape Earth's tectonic plates and their behavior over time. The weight of new water pressing into the old continental basins could cause geological instability, earthquakes, landslides, tsunamis. Conversely, the immense reduction in water pressure atop the new continental plateaus could trigger volcanic eruptions as depressurization unleashes pent-up energy beneath the crust. Over centuries and millennia, life would begin to claw its way back. The new highlands, swept by wind and rain, might slowly develop pockets of soil, encouraging hardy mosses and grasses, then trees. The new seas, only hundreds or thousands of meters deep, would quickly receive sediment runoff from their enclosing mountain walls. Algae would bloom, then fish and other marine life, evolving to match the new conditions. Humanity could adapt as well. The challenge would be extreme, but our species, with its tools, technology, and ingenuity, might find ways to flourish once again. But step back, and the full significance of such an inversion becomes even more awe-inspiring. Our cultural heritage, art, literature, architecture, would be lost beneath miles of water. Ancient ruins like the pyramids and Machu Picchu, submerged. The great libraries and capitals of civilization, inaccessible, preserved only as watery tombs. Humanity would have to rewrite its history, start anew, and relearn lessons, scientific, philosophical, moral, once painfully acquired. And yet the story of an inverted Earth is not simply tragedy on a global scale. It is a story of adaptation and evolution. Old pathways to survival would lead to unexpected places. Societies may form around the new coasts, the shorelines of the former highlands, or in sheltered pockets where conditions are more favorable. The relics of the oceanic world, a fossilized whale on a windswept plateau, the corroded shape of a sunken ship now resting upon a mountain peak, would provide reminders and mysteries for generations to come. The geography of war, trade, and migration would shift. If the new seas remain isolated by mountain escarpments, nations might find themselves more isolated, less likely to trade or interact. Alternatively, new passes or navigable rivers out of the immense continental basins could serve as vital lifelines, fostering cultural exchange and economic growth. Would we ever learn to look up at the sky and see, nestled atop distant mountains, the fossilized remains of sea creatures, the ammonite, trilobite, or ancient fish, reminders of the world as it once was? Would future poets and philosophers ponder the meaning of these changes, finding metaphors for struggle, rebirth, and adaptation? Of course, the inversion of Earth's topography is impossible as we know it. The great forces that shaped our planet, plate tectonics, water cycles, erosion, and sedimentation, do not allow such sudden changes. But the universe is full of unpredictable events, comet impacts, planetary collisions, sudden and catastrophic geological upheaval. And as thought experiment, the inversion offers a window into our own fragility and resilience. Consider for a moment the changes in culture, in language, in myth. Old names would gain new meanings. The word ocean would refer not to watery depths, but to rolling, barren highlands. Mountain would mean a great, plunging abyss, perhaps dark, cool, and teeming with life. Cartographers, explorers, and scholars would labor to map and classify this new world. And then, of course, there are the questions of time. After the initial trauma, centuries might see new civilizations rise. People would form new countries, cultures, and faiths based on the unique landscapes around them, worshipping the gods of the high plateaus, telling stories of the ancient drowned lands, inventing rituals and holidays to mark the moments of birth and destruction. Children would learn to ski or ride animals across vast oceanic plains, now perched miles above sea level, and would peer down the sheer walls into the green and blue of the new inland seas below, wondering at the mysteries awaiting beneath their surface. Scientists and dreamers would wonder what might be found fossilized in the new cliffs, or what lessons the cataclysmic inversion could teach about survival, technology, and hope. This world would see great challenges. Massive winds might sweep the new highlands, unchecked by trees or hills. Weather patterns would be violent in their infancy, as the atmosphere struggled to adjust to the sudden change in thermal and physical boundaries. At the edges of the continental basins, trapped fogs and rains would create unique microclimates, perhaps lush jungles in the shelter of towering cliffs. Culturally, humanity would be both traumatized and invigorated. The sense of loss would be immense, but the drive to rebuild and explore, to uncover and master the new world would call on our noblest traits. And in the fullness of time, perhaps the world would stabilize. Great cities would arise atop the plateaus, hardy crops bred for thin air and cold nights. New myths and traditions would grow around the memory of the inversion, the fall, the rising, the day the earth turned. And beneath the new seas, somewhere deep in the forgotten valleys that once were crowned by snowy peaks, the ruins of ancient humanity would rest, awaiting discovery by explorers of a future era. The inverted world would be a planet of extremes and inversions, of old mysteries and new beginnings. It would force us to reconsider our relationship to the land, the water, the atmosphere, to see, perhaps, that everything which seems permanent can change, and that every end is a beginning. From the vantage of Mount Challenger, once the deepest part of the Pacific, now the highest point on Earth, a lone explorer might gaze out over the endless plateau. The thin air wheezes in their lungs. The winds howl, and, far below, clouds gather in the old continental trench, now an inland sea. Somewhere down there, hidden beneath the surface, lies what is left of the old world. Lost, but never entirely forgotten. Thus, the inversion of Earth's topography is not merely a question of physical geography, but of imagination, a lens through which to consider the resilience of life and the endless play between creation and destruction, loss and renewal, that defines our world and our species.